40 seconds for a whole car? I still can't believe it.
Standing in the scorching Texas plains, Giga Texas rises like a futuristic city amid the desert. The factory spans an area equivalent to 15 football fields, designed from the ground up for maximum speed, precision, and scalability. Elon Musk's vision was never about incrementally improving existing assembly lines. He imagined a facility where software-driven efficiency meets industrial-grade robotics, where humans supervise, optimize, and innovate, while machines execute the work with near-perfect accuracy. Walking along the main production floor, one sees robotic arms stretching like steel giants, welding, assembling, and inspecting each vehicle with micrometer precision. Autonomous guided vehicles. AGVs silently ferry components across vast distances, choosing the most efficient routes while avoiding collisions. The Gigapress stamping machine, capable of exerting 10,000 tons of pressure, presses an entire car frame in a single operation, replacing dozens of manual steps and ensuring structural perfection. Humans in this ecosystem are no longer burdened with repetitive labor. Instead, they oversee, analyze, and refine the process, ensuring that every car meets exacting standards while the machines handle the heavy, continuous work. The factory operates 24/7, self-healing when equipment malfunctions, demonstrating a level of automation and intelligence previously unseen in automotive manufacturing.
Tesla has redefined what a factory can be. The speed of production, the seamless collaboration between AI, robotics, and human oversight, and the ability to continuously self-optimize is staggering. This facility doesn't just build cars, it builds a new model for industrial efficiency and sustainability, one that could influence the entire automotive sector worldwide for decades to come.
Inside Giga Texas, specialized lines produce the modern e-SUV, the futuristic Cybertruck, and the upcoming low-cost Modern 2. At the heart of each vehicle is the 4680 battery, Tesla's next-generation cell that promises higher capacity, faster charging, and longer lifespan, critical for making electric vehicles accessible to millions. The factory also demonstrates Tesla's commitment to sustainability. Solar panels blanket the roof, powering operations with renewable energy. Water recycling systems conserve every drop, and surrounding green spaces maintain ecological balance. It's proof that industrial-scale production can coexist with environmental responsibility, aligning rapid technological progress with a sustainable future.
From a manufacturing perspective, what Tesla has achieved here is revolutionary. They've designed machines that monitor themselves, adapt in real time, and even correct errors autonomously. The integration of AI at every stage, stamping, welding, painting, assembly, is unparalleled. This is a blueprint for the future, showing that industrial production can be not only faster and cheaper, but also smarter and far more sustainable.
Giga Texas is more than a factory. It is a symbol of industrial transformation, where speed, precision, AI, and human expertise converge. The astounding reality, a Tesla rolling off the production line in just 40 seconds, challenges the imagination and sets a new benchmark for what is possible in manufacturing. Part 2, Technology and Smart Robots.
I've been waiting to see how Tesla would actually build this car. Not just the final product, but every step, the presses, the robots, the paint, all of it. Watching a car being born this way feels like being part of the future.
If Part 1 revealed why Tesla had no choice but to reinvent its process, Part 2 explains how the company actually pulled it off. The answer lies in a radical convergence of robotics, AI, and industrial design. For Tesla, shaving the production cycle down to just 40 seconds wasn't about working faster. It was about redesigning the entire system around speed, precision, and adaptability. At the core of this transformation is the Gigapress system, an evolution of the Giga casting method Tesla pioneered. Instead of welding together dozens of separate metal components, the Gigabredd can stamp large structural parts of the Model 2's frame in one seamless motion. Each press cycle takes less than 10 seconds, creating a rigid backbone for the vehicle with fewer joints, fewer welds, and far less complexity. But what makes the line extraordinary is not just speed. It's the intelligence layered into every step. Hundreds of robotic arms, each outfitted with adaptive sensors, perform assembly with near-organic coordination. These arms aren't programmed with fixed motions. Instead, they use self-learning algorithms that refine their accuracy over time. A robot may notice that a battery pack is misaligned by a fraction of a millimeter, correct the position autonomously, and then integrate that knowledge into its future operations.
Traditional assembly lines rely on rigid programming. Tesla flipped that logic. By giving each robot a feedback loop powered by AI, the system behaves more like a swarm of intelligent agents than a row of machines. They don't just execute, they adapt, which is the only way to sustain 40-second cycles without breakdowns.
Beyond the robotic arms, AI surveillance towers stand over the line, continuously scanning every unit. These towers use computer vision to detect surface imperfections, wiring anomalies, or coding inconsistencies. Unlike human inspectors, the AI doesn't blink or get tired. It can process hundreds of checkpoints in milliseconds. Then comes the paint shop. Traditionally a bottleneck, Tesla re-engineered it into a closed-loop chamber where electrostatic precision sprayers coat the car body in under 8 seconds. Each spray pattern is optimized on the fly, guided by data from microsensors that track paint thickness at the micron level. The result? Consistent finishes without the costly waste that plagues legacy automakers. One of the most futuristic aspects is what insiders call the self-healing factory. Tesla's AI doesn't just detect product flaws, it monitors the machines themselves. When a robot joint shows early signs of wear, predictive algorithms trigger micro-maintenance routines. Tiny adjustment bots lubricate, calibrate, or swap parts before breakdowns occur. This immune system ensures uptime stays above 99.9%, critical for sustaining the blistering 40-second tempo. Equally vital are the AGVs, automated guided vehicles, zipping across the plant floor. These autonomous carts ferry batteries, panels, and chips with choreographed precision. They don't follow fixed tracks but instead respond dynamically to traffic, avoiding collisions while maintaining just-in-time delivery.
The brilliance isn't just in robotics, it's in orchestration. Every second is accounted for. The Gigabredd press, the robot swarm, the AGVs, the AI towers, they're all nodes in a single nervous system. That's how you compress a process that once took hours into a window smaller than a minute.
Interestingly, this shift has transformed human roles. Tesla's plants no longer employ large crews for repetitive assembly. Instead, workers focus on supervision, data interpretation, and precision oversight. Human judgment comes into play when anomalies escape machine logic or when systems need re-optimization. For operators, the job feels less like factory labor and more like air traffic control, monitoring streams of data and intervening strategically. Dr. Daniel Lee, reflecting after touring Tesla's Texas facility, put it bluntly.
Walking the floor, I realized this wasn't a car factory in the traditional sense. It felt like stepping into a living organism, everything moving in sync, almost breathing. It made me think, if they can build cars like this, what else could they build in 40 seconds?
Ultimately, the magic of the 40-second Model 2 lies not in speed alone, but in systemic intelligence. Tesla didn't just add robots. It created a production ecosystem where machines learn, adapt, and even heal. For the automotive industry, this isn't merely a competitive advantage. It's a paradigm shift. Number 3. Vehicle lineup and 4,680 battery. When stepping into Giga Texas, it's impossible to ignore the diverse lineup of vehicles rolling out of its automated lines, each model representing a different piece of Elon Musk's broader vision. At the foundation of this vision are four key vehicles: Modern E, Cybertruck, Surma, and the long-awaited Modern 2, all powered by the revolutionary 4680 battery. The Modern E stands as Tesla's mainstream SUV, striking the balance between style, practicality, and accessibility. It's compact enough for city life, yet spacious for families, blending Tesla's futuristic design language with affordability compared to older models. The Modern E has quickly gained traction among young professionals and family buyers alike, making it Tesla's global market spearhead. Then comes the Cybertruck, the polar opposite in philosophy. With its sharp, angular design and stainless steel body resistant to bullets and dents, it's not just a pickup truck, it's a statement. Tesla even dedicated an entire production line inside Giga Texas solely to this model, underscoring its importance in Tesla's long-term roadmap. Meanwhile, the Surma, Tesla's commercial semi-truck, targets logistics and freight companies. By combining massive energy storage with AI-assisted driving systems, Surma promises both cost savings and emission reduction. It represents Musk's ambition to extend electrification beyond personal transport and into the backbone of global commerce. But the model that could truly reshape the future is the Modern 2, priced between $10,000 to $15,000. If successful, it could democratize EV ownership worldwide, turning Tesla from a premium brand into an everyday household choice. At the heart of all these vehicles lies the 4680 battery. Larger in format than traditional cells, it offers greater energy density, faster charging, and a longer life cycle. But beyond raw numbers, the 4680 is engineered for scalability. Its simplified design reduces production costs and aligns perfectly with Giga Texas's mission: build faster, cheaper, and cleaner.
The 4680 cell is not just a battery, it's an enabler. Traditional cells required complex assembly with thousands of welds. The new cylindrical format reduces that complexity drastically, lowering both cost and error rate. More importantly, its energy density allows Tesla to increase range without inflating the vehicle's weight, a breakthrough that competitors are still years behind on. When you pair this with the sheer output speed of Giga Texas, you have the formula for mass adoption.
While experts analyze the technical depth, car enthusiasts feel the emotional pull.
What people underestimate is how AI bridges the factory and the vehicle. The same predictive algorithms that allow robots in Giga Texas to self-correct are now extending into the cars themselves. Battery management, predictive maintenance, adaptive performance, it's all part of one ecosystem. Tesla isn't just building cars, they're building living, evolving machines.
Together, the Modern E, Cybertruck, Surma, and Modern 2 showcase Tesla's multi-pronged strategy: capture mainstream buyers, dominate niche segments, revolutionize logistics, and open the gates of EV ownership to the masses. With the 4,680 battery as the foundation, Giga Texas isn't simply manufacturing cars, it's manufacturing the next chapter of transportation. Number 4. Global impact and sustainability. Tesla's Giga Texas changes the game with sheer production speed. 2 million cars annually, with one car completed every 40 seconds. This output isn't just impressive, it forces the global auto industry to adapt. In the US, legacy players like Ford and GM must accelerate electrification or risk losing mainstream buyers to Tesla's cheaper, faster-produced EVs. In Europe, stricter emission laws collide with Tesla's ability to flood the market quickly, leaving Volkswagen and Renault scrambling. In China, Tesla's challenge is BYD, but Giga Texas scale reduces costs enough to remain competitive. For Southeast Asia, the factory's affordable models like Modern 2 could introduce millions of first-time EV owners, reshaping demand almost overnight.
A vehicle leaving the line every 40 seconds doesn't just represent speed, it's disruption. Automakers that still operate on older cycles can't simply catch up by tweaking processes. They need to rethink factories from the ground up or risk being left behind. That's why Giga Texas matters. It shifts the baseline for the whole industry.
Beyond competition, sustainability defines Giga Texas. Its roof is covered with solar panels, powering much of the facility. Water recycling systems minimize waste, especially in paint shops. Even the site design includes green zones to offset industrial impact, blending efficiency with ecological responsibility.
When I saw those massive solar roofs, it hit me. This isn't only about cars, it's about showing the world that manufacturing itself can be clean. As someone who's watched factories my whole life, the idea that each Tesla carries not just electric power, but a green production story is powerful. It feels like part of a bigger shift.
Tesla also addresses the toughest sustainability challenge: battery materials. Through closed-loop recycling of 4,680 cells, valuable metals are recovered and reused. This lowers environmental footprint and shields Tesla from volatile mining supply chains.
Solar panels and water recycling are important, but the real leap is in resource loops. By turning batteries into recyclable assets, Tesla reduces long-term costs while cutting dependence on raw mining. It's a self-reinforcing cycle. Scale up production, recycle more material, cut costs again. Very few companies have even attempted this at Tesla's scale.
Giga Texas, then, isn't just a megafactory. It's an industrial ecosystem. Competitors may match Tesla in vehicle design or marketing, but replicating a plant that produces millions of EVs sustainably is far harder. This mix of speed, scale, and sustainability is Tesla's real advantage. Number 5. Challenges and Tesla's future. Behind the sleek efficiency of Giga Texas lies a history of immense obstacles. Building the world's most advanced auto plant was far from smooth. First came the location decision, balancing land cost, logistics, and access to talent. Then the COVID-19 pandemic disrupted supply chains and delayed workforce mobilization. Coordinating hundreds of contractors on site, each responsible for different aspects of construction, was like conducting an orchestra without missing a beat. And finally, the challenge of installing gigantic machines, such as the Gigapress, required precision engineering on a scale few companies could even attempt.
People see the 40-second assembly line and forget the years of pain that came before it. Securing permits, training thousands of workers in new processes, and integrating robotics at this scale. It's a logistical and organizational marathon. Giga Texas is impressive because it exists at all, not just because of how it performs today.
With those foundations set, Tesla now looks forward. The company's long-term strategy extends beyond producing millions of cars. Expansion of production lines will allow Tesla to meet global demand more quickly, while the Modern 2 aims to make EVs affordable for nearly every household. Alongside cars, Tesla pushes its AI programs from full self-driving systems to Optimus, the humanoid robot, designed to perform repetitive tasks in both factories and households. Automation, guided by AI, is positioned as the backbone of Tesla's future.
What excites me isn't just Tesla's cars, but the ecosystem forming around them. Optimus isn't science fiction, it's a natural extension of the same robotic intelligence used in Giga Texas. Once scaled, it could shift how labor itself is valued. Combine that with Tesla's AI data advantage, and you have a company not just building vehicles, but redefining what a factory and even a workforce look like.
Still, risks remain. Global competitors such as BYD, Volkswagen, and Toyota are racing to catch up. Political uncertainties, trade restrictions, and raw material shortages could slow Tesla's ambitions. And scaling Optimus or full autonomy from prototype to mainstream adoption will take longer than headlines suggest. Yet Tesla's edge lies in its ability to lead not just in products, but in production philosophy. Faster, greener, and smarter manufacturing makes competitors play on Tesla's terms, even if rivals match Tesla's models, replicating the synergy of Giga Texas, where robotics, AI, and sustainability converge, remains a towering challenge.
When I look at Tesla now, I don't just see cars. I see the start of something much bigger. It feels like standing at the beginning of a new industrial era, where speed, sustainability, and intelligence are built into every machine. For someone who grew up loving engines and horsepower, it's surreal, but also inspiring. Tesla makes me believe the future is closer than we think.
Tesla's journey with Giga Texas is far from complete. But one truth is clear. The company has redefined what a factory can be. From overcoming construction hurdles to envisioning a future of affordable EVs, humanoid robots, and AI-driven automation, Tesla has positioned itself as more than an automaker. It's a movement. The challenges ahead are significant, yet so is the momentum. If Tesla succeeds, Giga Texas won't just be remembered as the largest EV factory in the world. It will be remembered as the birthplace of a new industrial revolution.